guys, we made it. Thank you. Thank you for bearing with us here and gathering here today. Well, we're here for the demo day of batch 2057. Elena Bardashevich, Ronok Patani. And so this first bit is I'm obligated by the franchise guidelines to say this, so just bear with me. Le Wagon was founded in France in 2013. We're up to 40 locations now around the world, and we help applicants break into the tech world. We provide the bootcamps of data science and AI, AI software, and data analytics. And this is our data science in the AI batch. And let me quickly boast a bit about everything they've been learning in the last 9 weeks. This is going to take a bit. So in 9 weeks, they learned Python programming for data science, including functions, loops, conditional statements, best practices in coding with AI, SQL and relational databases, data analysis using tools such as Pandas, NumPy, and Seaborn, statistics and linear algebra, decision science, machine learning workflow, building ML models, deep learning, generative AI, training and deploying models, project management with tech and agile and handling technical projects, and ethics in AI. So yes, that's everything they've been learning over 9 weeks. And I can proudly say these two students have been very bright, much smoother than usual bootcamps. Thanks also, of course, to Amit over there. Thank you very much. And yes, without further ado, I want to present the final project they've been working on for 2 weeks, where they brought everything you just heard together to, from scratch, build an AI app. Let's go.
So, hi guys, hope you're feeling well. I'm gonna go with Team 9, that's how we call ourselves, as you see from our logo. So, that's me, Elia, career software engineer in FinTech, and this is my lovely co-founder, Ronak, also in FinTech, product owner. So you'd say it's like a perfect team to build this, what you're gonna see later. So a little bit about the problem that we decided to solve. As many of you know that how difficult it is to keep track of your nutrition and how important it is for your life, how many carbs you consume a day, how your insulin gonna spike with that, and how protein deficiency can damage your life. So there's not that many things you can do. A lot of apps that historically people used for fitness and nutrition would involve typing in data into it, and how tedious that would be. You're about to have a meal and you have to open your phone and type every single ingredient that you have there. Why don't you use an app for it? Take a picture and it will tell you what's inside. So without further ado, I'm giving it away to Ronak.
Thank you, Elia. So, yeah, as Elia said, the problem that we wanted to solve was being able to give you very accurate macronutrient information from the image rather than having to weigh, etc. So to kind of go through this problem, we decided that we needed to train a model that is able to recognize this information based solely from a picture. We went through roughly this kind of strategy to get from an image to the end. So firstly, we need data. So in order to train a model, we need the model to know what a particular image consists of. So that involved data collection. We then needed to analyze that data to understand how the data spread, how best can we train a model to do this thing, which takes us to modeling. And then we created an app that helps the user go from picture to macronutrient data. So onto data collection. Sadly, we did not have the budget to have our own rig to take pictures, so we used a data set from Google. So what they basically did was they went to cafeterias in the US, and as someone is building a meal, they will take pictures using this rig. So there are overhead pictures being taken of every meal, so that's 5,000 in total. And they do videos, so you have a video of this dish being taken from multiple angles. So it basically goes around and it's done for 5,000 dishes, and every single dish is labeled with the ingredients and then mapped to FDA approved sort of calories and protein, etc. to it. So what we had was a Google Cloud bucket type thing with all of these videos and images, and we needed to extract that to get labeled information that we can feed into a model. So what we did was we created a script, and what the script does is it trolls through all of the images and videos, extracts them, and puts them into a file. And what it also does is it goes through all of the videos and extracts pictures. So we have a very consistent data set with images and I think it's the weight, protein, carbs, fats, and calories. So after this, we had a data set that we could work with. And I'll hand over back to Elia to talk about the analysis.
So we were looking at the few what we call in data science targets. So instead of sort of like a classic linear regression problem that you'd solve for one target, we had few. What does it mean? It means that we needed to predict not just one, but 5 of them. So we were focusing on total carbs, total mass, fat, carbs, and protein. So your meal, in your meal that we would need to predict 5 of them at the same time. It's already a complex problem. But when we were looking at the data set, what we first looked at, it's that target distribution. And if you can see from the histogram, it's really right skewed. What does it mean? It means the majority of the food items, dishes were lower in calories, lower in protein, lower in nutrition value. And you think like, what would it mean for us and for our research and for the program that we're writing? It means that if we were just to take this data and use it for a model, our model would understand how to predict a very low calorie food. But if you give it like a steak with chips and some sauce in it, it will get confused because the data that it would see mostly would be in a lower range calories. So how we approach this, we did a stratified sampling, which means that we composed. Oh, my nose disappeared. Oh dear. Stratified sampling means that we distributed all the data proportionally equal according to their nutritional value, so that we can take a sample that represents each of the categories. So we don't have just low calories, just low mass, but we have equal proportion of that. And we started our training with that set, like starting from like 20% of that completely distributed data and increase it gradually to scale it up.
Sweet. So then that took us to modeling. So as Elia mentioned, once we have our samples, we can start gradually training a model with larger and larger data sets so that we don't waste too much time training a model, basically. So just to be clear, the input for this model is the image itself. The output is the calories, weight, protein, fats, and carbs per image. So we went for a model type called a convolutional neural network. So these are most appropriate for image recognition tasks. And I guess in the simplest way, what it is essentially doing is images are basically fed through a network of filters. So you can think of it as taking your image and filtering it so that it can extract features or very visible things. So for example, in your first layer, it might be filtered in a way where it can see the outline of a dish. In the next layer, it might be able to see like more finer details within the middle of the dishes, for example. And it kind of keeps going through multiple layers. And in terms of scale, you can think of it doing this thousands and thousands of times. I think there's a GIF that I will show you, which hopefully brings that to life a bit better. And I guess what this one is basically showing you is that it's scanning the image pixel by pixel in a way to apply the filter. And this little green thing over here is the thing that determines the filter. that green square has a bunch of, we can call it weights, or just things that you can change to make the filter different. And what our neural network will do is it will update these weights to make the filter clearer and clearer for it. So this hopefully brings to life a little bit what's happening once it starts playing. So basically, on the left, you can see you have an input. Each layer is basically trying to extract information from the input. So in this example, you can see it can recognize the number 4, or the number 1 in this case, from the first layer. As you go deeper and deeper into the layers, you actually don't necessarily know what it's doing, which kind of makes it a bit of a black box. But hopefully this kind of brings to life the kind of thing that's happening thousands and thousands of times. So yeah, that's vaguely what we're doing. And just a little bit about a sort of method called transfer learning. So when you train such a model, as we just saw, it basically learns all of those weights. It's tuning those weights to basically make sure that it's as accurate as possible. Transfer learning basically means that we can stand on the shoulders of giants and use their pre-trained models with millions and millions of weights already pre-tuned to generically recognize images. So transfer learning is basically a way for us to use these pre-trained weights. And what we can do at the end, and you can see this in the blue at the end, we can just take that output and then run it through our own neural networks to be very specific to our task, which is to predict the macros. So what we did was we sort of began with the very basic one and we kind of built up and utilized transfer learning and convolutional neural networks. Which then leads to our model.
Yeah. So base model is that what we have from the transfer learning. So we take in Google's model, and I think that is Google's model.
This model is the basic one, not transfer learning.
Sorry, no. Yeah, so transfer learning. We end up with quite a big model. If you can see, the total parameters it's over 120 million. Like there's like a data point that we need to go through. But what we end up training is the 4.7 million. So that's quite a small chunk comparing to the big one. So the 120 million, 120 plus million is something that we don't need to, we just take it as it is. And that helps us to teach our model how to act on the 4.7 million of trainable parameters. This is the end result model. As you can see, it is quite long. Those are the layers that the layers of the neural network. It's combined transfer learning, so the one that we got and the model that we built on top of that. And it keeps going.
We're not even halfway.
Yeah. Here we go. We're almost at the end of it. Yeah. So you see, quite a substantial amount of training to do.
Where have this?
And I think we transitioned to not the results. Where is the results? Yes. Considering this a 2-week project, the amount of data and the resources that we had, I think we achieved pretty incredible results. So it's 0.83 accuracy, which somewhat can translate to percentage of accuracy, not quite, but you in your head you can understand that it's somewhat in the range of understanding like how accurate the model is. So like it's 83% accurate, not exactly percentage, but to translate it into words. So that, without further ado, I think we're gonna transition to our demo. Let me know who of you is hungry. Oh, here you go. We have an audience person. We're gonna get you a plate.
That's good.
What would you like to have? This is present.
Would like some chicken.
All right.
We
Yes. Anything else?
and some vegetables.
Some vegetables. All right, let's see. Do you know how roughly to estimate this meal? Like, what would you consider this to be in terms of your nutrition value?
Question.
Yeah, so good. Maybe everyone can guess.
Try to think about it while I'm setting up the
If
demo.
you want to see it.
Do we get like calories or grams of protein?
Any of those. Well, in total, it'll give you the weight, calories, protein, carb, fat.
Sweet.
What do you think it might be?
Right. 300 calories.
Okay.
Down. 20 protein.
Okay.
And then carbs like 0 fat.
0 fat, 10 carbs. All right. That sounds reasonable, I think.
How much?
We said 20 grams of protein.
15
15. All right, and you said 300
Yeah.
grams mass or
calories.
300 calories. All right.
I think you guys need to gather
Yeah,
around
let's come a
here.
little bit closer, 'cause you're
We
gonna
only
show-
can present it from your phone. We developed an iOS app for that so that you can take a picture and see the
If you like
results that our model is producing.
I was thinking 25 grams.
25 grams of protein.
That's a gram.
Well, let's
I
see
would
it.
believe that. I would believe that.
All right, here we go. Take a picture and upload it. There we go. All right. Check what we have.
14 grams of protein.
Oh,
Okay. Pretty good.
Yeah, fat.
We only had 2 weeks, so there's a lot more that you could do with this. One key thing I think is it currently just looks at the picture and it gives you the macros. If you're using an app, you maybe want to know what it thinks your meal is, so you know it's being accurate. So the data set already tells you from the training data what the ingredients are. So what you could do is build a much more complicated model that instead of predicting all of these numbers, it can predict the ingredients on the dish and then look up on the accurate sort of macro details per gram or whatever and then give you that. Another thing is adding volume and distance, so using the LiDAR, I believe, on the iPhone camera to get the distance. One thing we didn't mention is the dataset also had that information, so they took overhead images and they used, I don't know what they used, but it was an RGB image that could tell you the distance between the camera and the dish, which will give you much more accuracy. We just didn't have time to incorporate that, but we definitely would. There's a bunch of other sort of technical things that you could do to make the model understand more variability in dishes. We could probably even add more diverse foods. I think this is not very diverse as a data set. And then run it for longer, run it through much more. And then if you wanted to make this into a product, if we wanted to do that and try and get the funding, it would need to be able to log macros. So you want to be able to see on a daily basis what you've been logging, display the dishes, like I said, batch uploading images, and then maybe even if you don't have an image, maybe you can speak to your phone and tell it what you ate, and then it can use the same model or similar lookup to tell you the same information and logins. And this is just 2 or 3 things that you could do, but you could do much more. So yeah, that's it. That's our model. That's the results and everything. Thank you for listening. If you guys have any questions, we're happy to take them. Thank you. My name is Ronak. I'm from the UK, from London.
Hi, my name is Elia. I'm based in London.
So I was in a transitionary period in my career and was looking for ways to upskill, become a bit more technical, learn more about data, and just get more clued up about AI and how it works and how the inner workings are. I was looking at multiple options and I found the Wagon website and decided that Bali would be a great option. Vince was very good at giving me some people that I could speak to understand about how the bootcamp works and understanding how it's run before. And it just seemed like a great location to do it.
Well, I left my previous place of work, and I have been in tech for quite some years. And I wanted to have some sort of a sabbatical, but sabbatical in a way that I will do something different to myself. Funny enough, that's something different I decided to still do in tech. So I wanted to have a combination of holidays, sort of like tropical location, but to still engage my mind and in some different activities to what I normally do.
Yeah, absolutely. I think if you're the kind of person that needs a bit of structure, you've maybe tried learning on your own and you feel like you need a little bit more of a directed approach, a schedule, a structure, I couldn't recommend this anymore. Like it's great teachers, very complicated topics condensed in a very short period of time. It's easy to just be in a position where you're not learning anything and you're just kind of listening and not gaining anything from it. But I think the way this is structured, the way the teachers are, the way it's being taught, and the way that you have so much time just coding every single day and then spending direct time on the project, it's just amazing. So yeah, couldn't recommend it any higher.
Yes, absolutely. Absolutely, I would recommend that. We had an incredible teacher, and as I said, I'm already have nearly 10 years in tech, and I can say that there's been pretty good quality of tech education, and especially in the space of time that we're doing the bootcamp.